Okay students, now we are going to see the logical instruction RAR. So in this instruction, the whole instruction is considered as opcode. So opcode is RAR. There is no operand present in this instruction. If you see in this instruction, no data is present. It means this instruction is of 1 byte. Machine cycle, we are going to see that. Before, let's see the meaning. Now RAR. RAR means rotate content of accumulator right. I am repeating, rotate content of accumulator right side with carry. So before the execution, you can see that the content of accumulator is 15H. The content of carry flag is 1 and accumulator is represented as bitwise. So if you convert 15H into binary, you will get some data like this. So same accumulator is represented bitwise. So before the execution, the content of accumulator carry is this. Now the example is RAR. What is the meaning of RAR? RAR means rotate accumulator right side by 1 bit. I am repeating, rotate the content of accumulator right side by 1 bit with carry. So you can see that the accumulator contains this value and the carry contains 1. When this instruction is executed, all the bit in the accumulator will be shifted towards right side. So the content of D7 will be shifted to D6. The content of D6 will be shifted to D5. Then content of D5 will be shifted to D4, D3, D2, D1 and D0. What will happen to the content of D0? The bit which is present in the D0 will be shifted to the carry, and the whatever content is present in the carry will be shifted to D7. Now can you tell me what will be the value of the accumulator when this instruction is executed? What will be the value of D7? You can see that in the D7 the carry is shifted. So you can see that in the D7 1 will be present, which is the carry shifted. What will be the value of D6? What will be the value of D6? So you can see that in the D6 the bit D7 is shifted to D6. So in the D6 there will be 0. In the D5 there will be 0. In the D4 there will be 0. Then in the D3 1, 0, 1 and 0. Now what will be the value of carry flag? You can see that the D0 is shifted to carry. It means the value of the carry will be 1. If you convert this number into hexadecimal, you will get 8AH. Now let's see the machine cycle. This instruction is of 1 byte. It means when you give this instruction in the memory, it will occupy only one memory location. So let's give the instruction to the memory. It will occupy only one memory location. Now when all the instructions are stored in the memory, the microprocessor will start its function, that is to fetch, decode and execute. To fetch the instruction, the microprocessor will perform the first machine cycle, that is opcode fetch. While microprocessor performs the opcode fetch, this whole instruction will be transferred to the microprocessor. Then processor will decode that instruction and it will execute. Now, when processor is executing this instruction, you can see that the content of accumulator and the carry flag is changing. The content of accumulator is shifted right side by 1 bit and carry flag, the value of carry flag is also changed. During the execution, is processor writing any data to memory or reading data from memory? No. During the execution, no memory interaction is done. What I am trying to say is, in this example, only one machine cycle is needed, that is opcode fetch, because all the process is happening within a microprocessor, and for that processor does not need any extra machine cycle.